I'm excited to introduce our keynote for No Coast, Kristen Hammer from Virgin Hyperloop. As many of you know, this has been a project that we have been actively involved in supporting this technology and making sure that Missouri can be one of the first places where Hyperloop can be available. And the reason why is because we already are a transportation hub. And because transportation has been an important part of Kansas City's history since covered wagons stopped here, resupplied, and went west, technology is finding its way into not only the transportation industry, but nearly every industry. Because that's already a strength of Kansas City, we're excited to bring Kristen to the No Coast stage. And really, this technology epitomizes No Coast. When this becomes real, our country will feel like there are coasts because these areas of the country will be so accessible from the middle to either coast. Hyperloop technology will get us there quicker and faster and safer than any other mode that exists today. Kristen, take it away.
Hi, everyone. My name is Kristen Hammer. I'm the Business Development Manager at Virgin Hyperloop. And I want to tell you today a little bit about our technology and a little bit about the role that I've had working with this technology and getting us as a company really to where we are today. So think a little bit about the last transportation innovation that we had, really as a society, as a world. Planes were invented over 100 years ago. So it's been a while. And of course, we've had incremental improvements in a lot of our technology since then. A lot of things are evolving lately, autonomous vehicles, electric vehicles, but there hasn't been a new mode of transportation in a while until Hyperloop, which is what we're working on now and what I want to tell you a little bit more about today. So think about the way that you travel. Imagine if you could go from Chicago to Pittsburgh in 60 minutes, or Chicago to Columbus in 45. Or if you're more familiar with Texas, think about a Dallas to Austin journey in 30 minutes, or probably a region that everybody is pretty familiar with. Think about getting to St. Louis in 30 minutes, or to Columbia from either Kansas City or St. Louis in 15 minutes. It's pretty revolutionary, right? It's a pretty big deal. That's really what we're talking about. So we're talking about a 21st century transportation technology, a new technology that doesn't exist or hasn't existed until recently. Let me tell you a little bit about the technology before we really dive into this too far. So people who have heard of Hyperloop most often know about the speed, or they've heard about the speed. So speed-wise, it's a pretty big deal. We can go almost 700 miles an hour or 1,000 kilometers an hour. Now, there's a couple of technical reasons that we can do that. First, you can see from this picture that we're inside of a tube. Being inside of the tube allows us to pull out most of the air, reduce the air pressure, and therefore reduce the aerodynamic drag, or basically the friction that the pod feels as it moves through that air inside of the tube. So that allows us to use less energy to go faster. Similarly, we are levitating our pod with magnetic levitation. So think about how two magnets can oppose one another or attract one another, and you could basically balance that out and keep a gap of magnetic air when you're kind of pushing magnets apart. And that's how we are floating the pod. So sitting on this little gap, and floating means no wheels and no wheel to rail or wheel to road in the case of a car, friction. And so that allows us to further use a lower energy solution for a higher speed result. And that lack of wheel on rail or wheel on road also reduces the maintenance required. So think about your car, you're replacing the tires every so often. Trains have a lot of wheel on rail maintenance as well. So we're eliminating that facet from the system. Our system operates pretty differently from a typical train as well. So we're fully autonomously controlled, and most of you are probably familiar with the autonomous vehicle technology that's developing. So a lot of the same types of technology are used in our system. So our pods are all controlled by a central command system, and they all are talking to that central control system as well as to one another. So that allows the pods to run much more closely together. And we know that this is a really safe system without any operator concerns. So we'll talk about that a little bit later. This slide is interesting as well because the way that we move people in Hyperloop is very different. So rather than a train that has one long series of connected vehicles moving hundreds or thousands of people in really effectively one vehicle, and therefore requiring it to stop at every station so that people can get out at the right station, we split people up differently. So if we're all in Kansas City on the Kansas City to St. Louis route, but I'm going to Columbia instead of St. Louis and you're all going to St. Louis, that means that I'm on one pod and you're on another. And my pod is going directly to Columbia and yours is going directly to St. Louis. And if my pod is in front of yours, then it won't slow you down because our setup is not like a train where everybody is sharing the same line of rail, but more like a freeway where if I want to exit, I take an exit ramp and I quickly exit, get out of your way at full speed, slow down on that ramp, and then come to my stop. And then if that pod fills up with some new people who want to go to Kansas City or St. Louis, then they merge back into the line in a similar way. We talked a little bit about the safety of an autonomous system and how that removes all operator error from the system, which is pretty exciting. But if you think about other reasons that a car or a train or an aircraft have safety issues, there's a lot of weather concerns. There are concerns of interacting with other forms of transportation. There are concerns with interacting with people or animals in the guideway. None of those apply to Hyperloop because of the fact that we're enclosed in our tube. So rain, snow, sleet, doesn't matter. The tube doesn't care. The pod definitely doesn't care. People can't get inside. Animals can't get inside. And it's really a very different scenario than a lot of existing transportation forms because of this enclosed system. Sustainability is one of the things that I think is really exciting to a lot of people. It's one of the most exciting pieces to me. And what's very cool about the Hyperloop system is that it's fully electric. So we are propelled and levitated with fully electric systems, which means that we don't have any emissions. There's no engines and exhaust like a car or a train. And it means that we are really as clean as the energy going into us. So if the electricity for the system is coming from solar or wind or hydroelectric power, then this is a fully zero emission system. And if it's not coming from one of those solutions, then we're still only creating emissions at the formation of the energy and not the actual travel mode. So it really allows the energy sources to develop along with us as the world moves towards a greener place. This is also a notable slide because you can see that the pod is inside of the tube, elevated up on columns. And what that means is we can take up a lot less space. And we can put this in different places than you'd often see a train structure. So if you build a train track, you might cut through a field or a forest and make it difficult for animals to cross from one side to another. If we build this up in an elevated fashion, then there's no such blockage there. And it means as well that we can put this in a more narrow guideway or more narrow corridor than a typical transportation system because we don't actually take up that much space. So think about maybe down the median of a freeway or other similarly narrow areas. We can just bring a nice new form of transportation in there. I'll show you guys a little bit of a video here. I'm going to stay on this slide for a bit because I want to talk to you not just about DevLoop, which is what you're seeing in the background here. This is our test system in Nevada, DevLoop being our name for the development Hyperloop system. We built this in 2016 and 2017, and it's the world's first full system Hyperloop at full size as well. So you'll see some videos scrolling through here of us doing different tests. And this is particularly relevant to me because my first job at the company was a welding engineer, and my responsibility was overseeing the welding and inspection in the company. And a lot of that welding happened on this tube structure. So this is a steel tube structure. There are some miles of welds. I should probably know that number, but each tube is welded to its neighboring tube so that we can build out a 500 meter length, excuse me. And all of those are fully inspected on the surface and inspected through their thickness. I oversaw the team that did all of that work. So spent a lot of time out in the desert working on this system and had really a lot of fun with that. The system is the third largest vacuum structure in the world by volume. So pretty exciting there. But what makes this a more sustainable system than a lot of vacuum systems that people are familiar with is that the pressure is much closer to that of air than that of space. So what that means is the difference in pressure between the outside of the tube and inside of the tube is not extremely high, and thus it's less likely to leak. So people who are familiar with the vacuum industry know that it's pretty easy to have a leak in a very low pressure vacuum. So we went for a vacuum that is just low enough pressure to give us that aerodynamic advantage that I talked about a few slides ago, but not so low that we're spending a lot of time and energy maintaining that vacuum. I want to talk a little bit more about the routes that we have. So we highlighted this one at the beginning, but just to show you in a little more detail, the Kansas City to St. Louis route. So probably many of you have driven this, 3 hours and 45 minutes if you're driving the speed limit to go from Kansas City to St. Louis. By Hyperloop, it's 30 minutes. And Columbia is a 2-hour drive or a 15-minute Hyperloop journey. So pretty exciting there. A couple of our other corridors in the US, Chicago, Columbus, Pittsburgh. So for those of you who aren't familiar with some of these drives, the Columbus-Pittsburgh is about a 3-hour drive as well. And the Columbus-Marysville journey that you see there in the middle that's a 7-minute Hyperloop is a little under an hour drive. We talked about this one at the beginning as well, a Dallas-Fort Worth corridor that goes down through Waco, Temple, Austin, San Antonio, and to Laredo on the border. Also a pretty exciting one because just that Fort Worth to Austin is also a 3-hour drive. So cutting a lot of travel time out of this. We don't just work in the US though. So we've done some feasibility studies in the Middle East, working with the UAE and Saudi Arabia, and looking at how we can really connect the entire Gulf area. So this is a pretty exciting corridor that really helped connect this region. And then in India, connecting Mumbai to Pune. So Pune is a small city by Indian standards, but about the size of LA or New York. And Mumbai is actually 20 million people. So huge, huge city there. And this connection cuts a 2.5-hour drive down to a 25-minute Hyperloop. And there are so many people on this corridor that this is really a full capacity system that can transport hundreds of millions of passengers per year. So the tech is really exciting. I think hopefully I've got you all pretty excited about that and you appreciate and understand that. I mentioned that I started at the company on engineering as a welding engineer, but my role now is business development manager. So I had over the years kind of been showing people the technology and sharing the technology with people. And when an opening popped up on the business development team, I was able to take advantage of that and move teams about a year ago. So what I'm working on now is the Hyperloop Certification Center. And this is really the follow-up to the DevLoop work and the test work that we've done in Nevada. So what we've done in Nevada is really a proof of concept. It shows the world that Hyperloop exists. It allowed us to do quite a lot of testing, but it also allowed us to learn a lot of improvements we want to make to the system. So the Hyperloop Certification Center is using that improved architecture and really building out the system in a lot more detail. So where DevLoop was 500 meters of straight tube, about 1/3 of a mile, the Certification Center is 10 kilometers of more curved tube that follows more of the geography of the land and has turns and a high-speed switch. So it's a lot larger scale. And the purpose of this is to have a physical asset for us to bring regulators and certifiers to see and to work through the certification process for us. Because we don't have a regulatory framework for Hyperloop technology right now. It doesn't exist anywhere in the world. And we're working on it in multiple different countries and on multiple continents, but we haven't got that yet. So the Certification Center is really a big step in getting us from where we are today to where all of us are riding on Hyperloops in our daily lives. This is a project that we're going to really make the first big decision on this year in 2020. So we will determine the final location of the Certification Center by the end of this year, which is pretty exciting. The other half of the certification journey really is the regulatory framework. So having the test asset is huge, obviously, and similar to DevLoop, having the physical system there really helps people understand it and helps us ask a lot of good questions and demonstrate a lot of the good capabilities. But if we don't have a set of standards and regulations to follow, then it's only an exciting system to show everybody, and we're still missing that step to commercial operations. So we've been working on this in multiple countries and multiple continents, as I mentioned. And in the US, we've been working on this with the Federal Department of Transportation. And we've had a big step. So last year, Secretary Elaine Chao created the NET Council, which is the Non-Traditional and Emerging Transportation Technologies Council. And it was formed to look at technologies that don't really have a clean fit into existing regulatory standards. So things like Hyperloop, like drones, like autonomous vehicles. And we jumped on the opportunity to work with these teams and have spent a lot of time educating the council on what our technology does and what our goals are, as well as showing them all the work we've done that we expect fits into the safety framework. So just recently this summer, they released a guidance document for regulation of Hyperloop, which is a really huge step. This doesn't exist anywhere else in the world. And there's a lot more to go beyond that, but this sets up the pathway towards really creating a full regulatory framework for Hyperloop, which is really exciting. In Europe, we work with DG Move and Shift to Rail. So those are a couple of regulatory agencies, and they've been working on this as well. So for the last 2 years, these two agencies have been bringing together Hyperloop companies from around the world. There are a number of others that are working on this besides Virgin Hyperloop, and really working to figure out the best way to regulate and certify Hyperloop technology in Europe. And then we're working on this as well in the Middle East and in India. So that's the biggest piece of my technology overview. And I want to show you guys before I go here, just a little bit more about what I was able to do at DevLoop. So a little bit more about my history at the company. So as I mentioned, spent about 9 months out in the desert. So this is a nice picture of DevLoop and a couple of pictures of me and some other team members working on the system, and just the transition I've made. So these middle pictures might look familiar to some of you. We came to Kansas City with our vehicle, our pod. So this is the actual vehicle that we've tested in DevLoop, the vehicle that you saw in the videos. And we brought this to Kansas City last summer. And I spoke to a group of students at Mizzou and explained to them what we were doing. Then on the right is our pod tour stop in Dallas at Cowboy Stadium. And on the left is myself with our head of projects and our CEO. So this was after a visit to many of our congressional leaders on the Hill. So I've come a long way from hard hat and neon wearing inside of a tube on a construction site to speaking with Congress people at the White House. So thank you again for letting me kind of share our exciting technology and my journey of working on really many of the aspects of it. And I hope that you've all enjoyed this and can look forward to continuing updates from us about Hyperloop. Thanks, everyone.